We were wrong about the universe. The greatest barrier to crossing it is not darkness, radiation, or even the limits of our technology. It is distance. The nearest star is more than 4 light-years away, yet that is only the smallest version of the problem. Farther out, the distances become so extreme that even light can no longer bridge them, and beyond a certain point, the universe stops being a frontier at all. For most of the space age, we told ourselves the opposite story. Distance seemed like a problem technology would eventually solve. Ships once needed months to cross an ocean, until better engines made the same journey routine. Space appeared to be the next version of that story. Build faster rockets, develop better propulsion, and the stars would gradually move within reach. That belief still shapes how we imagine the future. We picture settlements around distant stars, remaining connected to Earth, as though space was simply a larger ocean. Humanity reached the moon in only a few days. Robotic spacecraft visited every planet in the solar system. Voyager One crossed the heliopause and entered interstellar space. Progress seemed steady. The distances were enormous, but they did not appear fundamentally different from any other frontier. They were simply waiting for a faster vehicle. But no ocean has a speed limit written into the laws of physics. Proxima Centauri, the nearest star beyond the Sun, is 4.24 light-years away. At Voyager 1's current speed, covering the same distance would take roughly 75,000 years. 75,000 years ago, there were no cities, no agriculture, and no written language. A spacecraft launched today would arrive thousands of human generations from now. The obvious answer is to go faster, but relativity changes the rules. The faster an object with mass moves, the more energy each additional increase in speed demands. As it approached the speed of light, the energy required would rise without limit. It cannot be done. Even a signal traveling at light speed needs more than 4 years to reach Proxima, and more than 4 years for a reply. The nearest star is not simply far away, it is separated from us by time itself. And Proxima is the easiest distance the universe gives us. Scale that problem up to the Milky Way. Our galaxy is roughly 100,000 light-years across. Even a message moving at the fastest speed nature allows could need 100,000 years to cross it. A reply could take another 100,000. A civilization might spread between the stars, yet its most distant settlements would never share the same present. By the time an answer arrived, languages, nations, and perhaps entire civilizations could have disappeared. Then the galaxy itself becomes only one island. Andromeda, the nearest major galaxy, is about 2.5 million light-years away. The light entering our telescopes tonight began its journey when early humans were already walking on Earth. A simple exchange with someone there would take at least 5 million years. At that scale, conversation stops being communication. It becomes geology. But the hardest distance is not created by empty space alone. It is created by expanding space. General relativity allows sufficiently distant galaxies to recede from us faster than light, not because they are breaking the local speed limit, but because the space between us is growing. We can still see some of those galaxies because the light reaching us began its journey billions of years ago, when the universe was smaller and the galaxies were closer together. But visibility is not reachability. In the standard cosmological model, a signal sent today toward a galaxy beyond our cosmic event horizon will never reach it, and light emitted there today will never reach us. We may still see that galaxy because the light arriving now began its journey long ago. It can remain visible as an image of its past, while being permanently absent from our future. Those galaxies are not waiting for a faster spacecraft. Under the physics we know, every road between us is closed. Physicists can describe theoretical shortcuts such as wormholes, but none has ever been observed. The best-known traversable models require exotic conditions that we have no idea how to produce or control. The universe is not a continent waiting to be crossed. It is an archipelago whose islands are being carried apart while the ocean between them continues to grow. And humanity has already sent one tiny object into the darkness between those islands. It has traveled farther than anything we have ever built, and still, on this scale, it has barely left home. That object is Voyager One, launched from Earth in 1977. Years later, Carl Sagan wanted the spacecraft to turn around and show us what home looked like from the darkness. On February 14, 1990, when Voyager was roughly 6 billion kilometers from the Sun, it took one final image of Earth. Our planet appeared as a point of light, less than a single pixel wide, caught inside a scattered beam of sunlight. Every person who had ever lived was inside that point. Every city, every conflict, every unfinished goodbye. Sagan did not see the image as proof that humanity was meaningless. He saw a fragile world surrounded by distances so large that even our greatest journeys barely register. Voyager carries that same hope in another form. Attached to the spacecraft is a golden record containing images, voices, music, and sounds from Earth, something another intelligence might one day find. But after nearly half a century, Voyager is still nowhere near another star. That is what cosmic distance does. It turns exploration into separation, and a greeting into a message that may outlive everyone who sent it. So perhaps the silence around us does not mean no one is there. Perhaps it means no answer can arrive in time. We are still trying to shorten that silence. Breakthrough. Starshot aims to demonstrate whether laser-driven nanocraft could make the journey to Alpha Centauri in just over 20 years rather than tens of thousands. It would be an extraordinary achievement, but it would solve only the smallest version of the problem. Can any civilization remain connected across an entire galaxy? Could the universe be crowded with life and still sound completely silent? And how much of reality has already moved beyond every message we will ever send? We began with the idea that distance was merely a number, something future engines would eventually erase. It is not. Distance decides which worlds can speak, which can answer, and which may never know that the other exists. That does not make exploration meaningless. It makes every signal and every step beyond Earth more precious. We are a species on a small island, learning to read light that has crossed oceans of time to reach us. Perhaps the deepest mystery is not whether anyone else is out there, but whether distance will ever allow two worlds to know each other. The universe may be full of life and still leave every world alone.